Hi, and welcome to the digital job site where the boards are straight, the weather's great, and there really is a board stretcher. This is the video portion of a blog post at the digital job site blog at findhomebuilding.com that I've entitled Deck Stair Layout 101. And what I hope to accomplish with this tutorial is to show the relationship between the rise and run dimensions a person gets using a stair calculator or doing the division to calculate the rise and run for a set of stairs. I want to show how to apply those numbers to the framing material so that you can do the layout for a stringer. The numbers are all the same, but the way they're applied to the stair stringer is varies depending on the material person's using, etc. So to do that, I created this model showing a simple set of deck stairs going from a level deck landing on a concrete pad. I'm going to shut the shadows off here and then back up a little bit. You can see how kind of set up this somewhat typical job site, a level deck coming down to grass or sod, and a set of stairs making the transition between the two. And the stringer is notched for the stair material. It ties in underneath the deck to some blocking, and it's all done by taking the math from the stairs or the math from the calculations, applying it to a piece of lumber, put a couple pieces of lumber on a sawhorse over here, and using a framing square, doing the layout, and then notching something like 2x12 to support the stairs in proper entity. So I'm going to start by moving this out of the way and then showing how I did the calculation for that set of stairs. And if this was a project you're working on, if you're going from a fixed deck height down to a dirt level, and in this case you'd be using a tape measure, I'm going to use the line tool, just draw down in the blue direction and then index this sod surface material I have here. And using the entity info box, you can see that from that deck to that dirt would be 53 and 23/30 seconds in one particular spot or another. Dirt is obviously nowhere near as obvious as this plane in SketchUp. And if you have the dirt conditions to work from, you can set your landing spot within a few inches of what that's going to be. It's not that critical. You can just set the slab to an even number, which is what I did for this model. Rather than using this number, I just rounded it off, and this time I'll index to my concrete slab, and you can see that, get rid of this one, choose this one. You can see that I made this 53.5. I just took an even number to work with, and then theoretically formed and poured this concrete slab 53.5 inches below the top of that deck. And if any of you have watched the Stairmaster series I did at the digital job site, it shows a similar process for calculating rise and run using SketchUp. And you can review that for a little more information, but I'll quickly go through those steps here to run through the process again. So there's our total rise height. You would have that from a measurement on a job site. And I'm just going to right click it and then choose the divide tool. And as I hover over the line, you can see SketchUp is dividing it into different lengths of different measurements. And my goal here, and the goal for stairs, is generally to choose the minimum number of rises that are less than 8 inches tall. So if I go with 6 segments, they're 8, almost 9 inches, that's too much. I'll click down to 7 and end up with 7 41/64, which is the number that we're going to use. It's less than 8 inches. And now that that line's divided, I'm going to delete 6 of those pieces and just leave one vertical individual rise staying there. For the purpose of the model, I'm showing a nominal redwood decking material, be 1.5 inches thick and 5.5 inches wide, with an 1/8 inch gap in the middle. which gives us a length of 11 1/8 inches. Not too tough a math there. And the tread width is generally, in the stairs that I build, the tread width, I'll make it an inch. I'll make the individual run 1 inch less than the tread width to provide a 1 inch nosing. It just makes the stairs more comfortable to go up and down. So our individual rise is 1/7 of the total rise. Our individual run is going to be 1 inch less than the stair tread. So we're going to go 10 space 1/8 and get our individual run. So if I take those two lines and use the move tool with the copy feature and type 5x, that runs the rise and run down to the slab. And it's not quite far enough, so what I needed to do is overwrite that with 6x, enter, and then adds one more step to my little line there. So what that line represents is the individual rises and runs that it would take to get from this deck level to that concrete slab level in equal increments. And to further demonstrate what that represents, I'm just going to take a line back on the green axis here, back to the face of that 2x6, up to the top of the decking, and then back to this first rise line. And what that gives us is a plane. I'm just going to set this over at the edge of the concrete slab, push it out to the other side, and presto, we have a set of stairs. Individual rise, individual run, all identical. And if we put a protractor line tool across the line of nosing, all the nosings are in a line and they're also coplanar, which is the purpose of doing the stair calculation, so that the stairs are all the same height. If a stair, any individual step, is off for whatever reason, if the layout process goes wrong and you get one step that's too high or too low in relation to the others, you'll trip on the different step every time. And the code that I'm used to working with says that no individual rise can differ from the rest by more than 3/8 of an inch. It makes a safe set of stairs for going up and down. But that gives you a quick idea of what the math, the calculations from the stair calculation look like. Individual rise, individual run, all equal. I'm just going to put this in a group. I've got another one of these over here, but we'll just use this one because they're identical. Just going to group this stuff. And then if we take our set of stairs and slide them back over this direction, and get it in the red direction. What did I do? I think I moved that 100 inches. Just going to move it a little bit more. So what you can see is the stair treads, the top and the front of these stair treads conforms to the geometry from the stair calculation. Individual run, individual rise each time. But the stair stringer itself is different. And so what I'm hoping to show in this tutorial is how to compare and relate the geometry to the actual layout. If I take this group here and move it down, let's see if that's what I wanted to do. Just want to take this and move it back to the stair stringer. It's not Z-flashing like I would expect it. But the stair geometry, individual rise and run, is the same as on the stringer. It's just offset from the faces that you walk up and down in a set of stairs. And to create from the stair geometry to create a stringer. Just going to move the, so I grab the, see if I can get this other group in here. I just want to move the stairs, not the geometry. Take that back. I want to move the geometry, not the stairs. Just move this guy over here 100 inches. And then work with our model here. Get rid of that guideline. And let's see, get rid of this, one of these stringer components, and show how I created that. So I've got these stair treads are oriented exactly like they need to be to end up with a set of stairs. So I'm just going to draw a box here. Which gives us a plane. I use this all the time, a drawing plane to create rafters and such things. So I'm going to make this into a group. If you've watched other ones of my rafter tutorials or various tutorials, I start with a drawing plane so that SketchUp just kind of behaves. Instead of trying to snap to all different things, it just stays nicely in the plane. So to create a stringer to support these individual treads in their orientation, I'm going to put a line here that represents our 1-inch nosing, and a line here that is the nosing line, or line of nosing there, which we want our stringer to be parallel to that line of nosing, and to get the maximum width and strength out of it, we want the edge of the 2x12 to be right at the peak of this little triangle here. That'll clear up here in a little bit. So we'll get rid of that line. And what we have then is we can take our line this way horizontally. That's our individual rise, and down here is our individual run. If we go into the end of the info box, you can see we got 10 1/8 inch run and 7 41/64 rise. And to do this quickly, I'm just going to move one of these up here, and then I'm going to take this, make a copy and move and go, oops, got a little sloppy there, and back up on that, select this again, move, control, click, click, 5x, enter. You can see there's a little snippet of blue line down here. I'm going to erase, delete that piece of line. That line is in length matching to the thickness of the stair tread in this case. If you're using an Ipe decking or a composite that was 1 1/8 or 1 1/4 thick, your treads would represent that. They would start at this corner and go back the width of your tread and come down the thickness of your tread, and the stair stringer would be notched accordingly to support them in the orientation they need to stay in. So let's do 2 more guidelines and then we'll move this out of here. We want our stringers to meet the underside of the decking, and I want to notch them cleanly at the thickness of the joists, which is what those guidelines are for. So now if we take I got out of group edit mode, and I'm just going to move this group out here in the open. 200 inches ought to do it. Go back into group edit mode here. This is the group we want to edit. And I'm just going to go from that line to there, delete this line, put a full length line in there, hit the escape key to get detach our line tool for a second. And then that's going to be the layout of our stringer. I've selected that, and the shift key, which inverts my selection. Get rid of these guidelines. Pull our stringer out to 1.5 inches thick. Take the same stringer and move it back 200 inches. Puts it right back where we wanted it. You can see how I created the stringer. Now if I take that one, it's going to explode this group. I'll probably regret that. Explode that group. So if I take both of these stringers and just move them out, let's go 100 inches this time. You can see there's a slight difference in the two. The one I just created doesn't have this extra notch. What that extra notch does is fits around this edge of board at the edge of the deck. In this case I just made it a single thickness. So I'm just going to draw a rectangle on here, and it's going to be 5.5 comma 1.5. Puts that little rectangle on there, and then we'll just push it out of the way. And now when we put our, you can see that both of the stringers have that notch in them. Put them back where they came from at 100 inches. You can see how they fit. Let me go into this group here. Oops. Just going to hide this decking for now. And get rid of my hidden geometry viewing there. And you can see how these stringers are now fit into this deck. I've got a little bit of a discrepancy with my blocks. I moved something there along the line and wasn't paying close enough attention to it. But there you have it. So the stringers fit nicely between this edge piece and blocking with a full 5.5 inches. You could make this extremely secure by nailing this blocking in or screwing it in and then screwing to the back of the stringer here, through this rim board into the face of the stringer there, and those babies aren't going anywhere. But my purpose in showing that process is you can see how this stringer cut in this configuration is going to support the steps where they need to be in the exact orientation. So I'm going to move that block back out of the way, and when we take one of these, take this stringer out of here, just going to put one out here in the middle of nowhere, and you could calculate this whole thing just by taking your dimension tool, and you can determine the length of lumber you'd need to create the stringer. 88, 59, 64 sounds like an 8-footer to me. All your individual rises, they're going to be the same. Individual runs are going to be the same. The bottom run is neatly 6 9/64 because we have a tread thickness taken off of that. You can get all the notching up here. Whatever this dimension, I just made this back leg 5.5 inches, just so it would give maximum purchase on the block, but there's nothing necessarily set on this length. That turns out to be 9 57/64 to get this 5.5. You got a 5.5 by 1.5 inch notch right here. You can take the protractor tool and figure out from horizontal, your stair angle is 37 degrees, and from vertical, your stair angle is 53, complementary angles for 90 degrees. And that gives you everything you need to adapt the rise and run measurements to a piece of lumber for a set of stairs. I'm just going to back these dimensions out of here. In fact, we'll get rid of that. And the same method applies to, I made a set of stairs over here to kind of show the example of adapting these numbers. Let's see, where did that go? 500, I must have gone 300. Yeah, 300 inches. I put my housed stringer deck example right here. I'm going to slide it over, and you can see that rather than have a notched stringer or a solid set of stairs like this that might be a set of concrete stairs, nope, jumped out of the way. I hate it when it does that. Get this thing to slide over here and cooperate. So all the stairs and steps in each one of these different sets of stairs, concrete, notched, house stringer, the rise and run is the same, but the way they adapt to the stringers is different. I'm going to move that thing out of the way and just show you this this housed stringer example. And I'm going to try, there we go. Let's move that over 20 inches. You can see that these treads, rather than being supported by a notched stringer underneath, they're supported by a mortise routed and chiseled into the face of a 2x12. And I created this 2x12 stringer in much the same way I created the notched one. I used the same stair geometry and just created notches, or just created a individual mortise, and then moved it and copied it and placed it, and then just made an opposite for the other side of the stairs. So I hope that helps you understand this process, thinking on the fly here. And if I take this stringer out here, I can do the exact same thing with this stringer, and the stair angles are going to be the same as before, the 37 and let's see, I went the wrong direction there. From this angle to horizontal is going to be the same, the 37 and 53. And then you can measure the notches for the top that fit around the framing on the deck. You can figure a height depending on what you want here, the amount of material between the nosing and the edge of the stair, all these dimensions. You can figure out the total length of a piece of lumber that would take to do this stringer. I'm guessing 8 feet will probably still do it. So that's the features or the benefits, the advantage of using SketchUp for this sort of calculation. But even without that, I hope that this will help you visualize a little more accurately what to do with the measurements you get out of a stair calculation calculator. There's an excellent one at blocklayer.com for just doing the math for these sort of things, and I reference, there's a link to that on the Digital Jobsite blog post. And the setup over here I put together as a representation of using a framing square to apply the measurements we got from the calculator and the connections and relationship we got from this tutorial, how those are applied to a 2x12 to do the actual pencil layout, so you can cut this layout. If there's interest in that, I can expand on the topic a little bit, showing how a person would go through this process by orienting the framing square, stepping off the dimensions, etc., to end up with completely accurate stair stringers for a set of deck stairs. Well, I hope that I didn't leave too many gaps in that tutorial. I hope that this provides some insight if you're attempting to work on a set of deck stairs. Anybody can do it. It's a matter of understanding how to apply the math for the layout purposes on actual lumber. So thanks for watching. Stay tuned to the Digital Jobsite for more information, and please comment on the videos with questions or insight into things I could include or shouldn't have included, and I'll try to accommodate. Thanks for watching.